Hello, class. We're going to continue our lecture on binomial distribution, section 6.2. And we're going to continue the problem that we were discussing in the first part of this chapter's lecture. This idea of flipping three coins. So again, defining the probability of success is the value P, and that would be 0.5. And so there's 8 possibilities, and we walked through this in the last lecture. And if you remember in the last lecture, we ended with using the spreadsheet to calculate the probability of getting exactly 2 heads. I'll just do that again. We go to more functions. We go binomial distribution. So the number of this case is 2, and the trials are 3, that's n. Probability is 0.5 of success. And when you're doing an equal sign in binomial, you type in false. And there is 0.375, and fractions, that would be 3/8. And so what I have written up here on the whiteboard now is this analysis of flipping 3 coins. And so our n value is 3. Our x value is the number of coins, number of heads, excuse me. And our p value is 0.5. So you could see 0.375 for p equals 2. So what happens if you have some different applications and you wanted to know some different ideas? So it's nice to start with this one. And what I'd like to do is to show you what I have in the slide here. Again, these are available on our Canvas site. And you could see that if you're going to use the spreadsheet, you have 4 inputs that you need for the spreadsheet, for the binomial distribution function in the spreadsheet. This number is the x value, and that would be the variable. For example, for 2 heads, we put in 2. Trials, the number of times we flip the coins, that would be 3. Probability is a success, and for flipping a coin, it's 0.5. And cumulative, so that is 2 possibilities. If it's x equals a number, where in that first case, x equals 2, you put in false, and it gives you a single point in the probability. You can only use the false when it's a discrete probability. When it's continuous, false doesn't make any sense. So we'll talk about that more when we get to continuous. This is a discrete. We're going to have 4 choices, right? 0, 1, 2, 3, 4. And so false makes sense in this case. If you type in true, it gives you less than that number. And it actually gives you less than or equal to that number. And so the idea of less than and equal to is an important concept when it's discrete. It's not very important when we get to the continuous, and you'll see the difference between the two when we get there. So if we go back to the whiteboard here, let's ask the question, what is the probability of you getting x less than or equal to 1 head? So what does that mean when we add up these probabilities? So that would be the probability of 0 and the probability of 1, right? Whoops. And so when you do that, we'd have to add those 2 up in the old-fashioned way, right? So that would be 0.125 plus 0.375. And if you add that up, the probability of getting a 0 or 1 would be 0.5. And so how do we do that on the spreadsheet? Well, that's a less than calculation. And so this would be the probability of X less than or equal to 1. And when you do that on the spreadsheet, it would be more functions, binomial. So in this case, we have 1, so we type in a 1. The trials are 3, so that would be n. Probability again is 1/2. And so this case, it is true. So it's going to add up 1 and 0, because those are the two that are less than or equal to 1, right? So if you type in true, you would see you would also get the value of 0.5. So that's one calculation. Say like we did this next one. And you can see that it's adding these two bar graphs here, right? And remember, when we add all these together, you always get the number 1.0, right? And so remember, every distribution works this way. All the probabilities added together equals 100% or 1. So like you were asked the question, not the probability of 1, but say like you were asked the probability of X being greater than 0. And so what is greater than 0? Greater than 0 would be 1, 2, and 3. So we don't have a greater than in the spreadsheet. So how do we do greater than? Well, remember, all of them are equal to 1. So we could do 1 minus the probability of X less than or equal to 1. And so what you do is you calculate sorry, there is a mistake on that. It's not less than or equal to 1, but it'd be less than or equal to 0, right? Because that would give you just this 0 point. So when you do that calculation, we would go back to the spreadsheet. And that would be 1 minus the probability of X being less than or equal to 0. And because 0 is the last number, you could actually put in true or false. But here's how you do it. It would be equals, and then 1 minus, and then you put in the binomial. And so in this case, trials again here would be 0. There's 3. Their probability is 0.5. And if we do 0, you would see that that gives you 0.125. When you subtract it from 1, you get 0.875. And so if you go back to our whiteboard here, you can see that if you add 3/8 and 3/8 and 1/8, you get 7/8. And 7/8 in decimal is 0.875. So you can kind of see how this works with regards to calculation. Last thing you do is, how do you calculate the probability of being in between 2 points? So say like I wanted to calculate the probability of a 1 or a 2. Well, in this case, it's pretty easy because we know we add those together and you would get 6 out of 8. But how do you do it on the spreadsheet when things get a little bit more complicated? Well, basically, because you're doing less than, you would do, first of all, probability of X less than or equal to 2, and you'll get 2, 1, and 0. But we don't want the 0, right? So we have to get the 0 out. But if you just subtract the probability of X less than or equal to 0, you'll get rid of the 0 and you get the 2 in the middle. And so how do we do that? Well, let's go back to the spreadsheet. So if you go back to the spreadsheet, we want the probability of X less than or equal to 2. Oops, didn't type that in correctly. Here we go, less than or equal to 2 minus probability of x less than or equal to 0. I keep forgetting to hit the shift key when I need to. So you could do that all in one cell, or you could split it up. I'll do it all in one cell. So this would be equals, and then you bring binomial function in, and the first one is the 2. So this would be 2, 3.5, and again, it's true because it's less than or equal to. And now we want to subtract. So if we subtract, put a minus, and more functions. Do this one more time. In this case, it would be 0, 3.5, and true again. And you would see you subtract the 2, you get 0.75, and that's actually the exact same number of 6 out of 8. So hopefully that helped kind of give you a simple example on doing these calculations. And you probably say to yourself, well, we didn't need to do all this fancy spreadsheet stuff with just 3 coins. And the answer is 100% yes. But once if you had 10 coins, 20 coins, 50 coins, that makes it really much more complicated. And you'll see that the spreadsheet or your calculator will give you a much better way to solve these problems than trying to do it by hand that old-fashioned way. And so moving forward, the book has this calculation of this particular problem with hand calculations. And what I'd like to do is follow this same problem using the spreadsheet again. And in the PowerPoint presentation, you'll see all these calculations with combinations, etc. So you can walk through those as well. But this is an example of one that you really can't do by hand in the sense of the old probability way. You really need to use the binomial distribution formula or one of your fancy technology like the Excel spreadsheet or your calculator. So let's walk through these and see how they go. So this first one says, find the probability that exactly 4 of the sample people use Pinterest. So the data states that 30% of the internet users use the image sharing website Pinterest, which is, that's a really good number, right? And so what's the probability of success? 0.3. And then we're looking at 15 users. So what is N? N is 15. So the first one is exactly 4. So if we go back to our spreadsheet, exactly 4 is equals. And so this would be P equal, or X equals 4. So how do we do that one? Well, it would be insert function binomial. And so now our number is 4, right? Our trials is 15. Our probability is 0.3, and since it's equals, we type in false. And you could see that it's 21.8, 21.9% in that calculation. So if we go back to this calculation, you can see how to do it. Now you can't because you're looking at me. Okay. So I think I might have not have shown the screen. So sorry about that. If I already have, then you're going to see it twice. But this is the answer. And let me pull up the spreadsheet and do it one more time. And so if we hit more functions in the binomial, you would see that 4 is the number we're worried about. Trials is 15. Probability of 0.5. And since it's equal, it is false. And so you look at that. Now the probability is not 0.5, it's 0.3. And when you type in the right numbers, you get 21.86%. And as I was showing you on the hand calculation, you see you also get 29.9%. And so the equals is usually the easiest one. Some of these other ones are a little bit tricky. And I always have to think, so let's work through these next ones together. So it says, find the probability that fewer than 3 people use Pinterest. So what does that mean, fewer? Well, if I think about it for a second, fewer than 3 would be, because it's discrete, it would be the numbers 2, 1, and 0. So if we look at that in the mathematical sense, right, that would be the probability of x being less than or equal to 2. So when we do this calculation now, we want to do less than or equal to. So in this case, we are going to do the true. So back to the spreadsheet. Let's make sure I get there this time. And so this one here is the probability of x less than or equal to 2. So in this case, we pull up the more functions, bring up the binomial. In this case, x is 2. Again, it's 15. Make sure you plug in the right numbers, 0.3 for probability. In this case, it would be true. And if you do that, the probability of getting 0, 1, or 2 is 12.68%. So if you went back to the presentation, you see how you have to do each one separately and then add them all together? Quite annoying. Let me rephrase that. Quite tedious. And so you see when you add all those up, you would get the same number as we got in the spreadsheet. Again, your calculators have the same. I'll show you that, just show you the slides in a little bit. So what does the next problem state? So find the probability that more than one person. So what do we do with more than one? So again, let's go back to the whiteboard. So this one says more than one. So mathematically, what do we do with that kind of statement and this discrete distribution? Sorry, I couldn't think of the word. So remember, more than one means 2, 3, 4, ... all the way up to 15. So again, remember, if you add up all the probabilities, 0 through 15, it always equals the number 1. And so to use the spreadsheet, if we get the numbers 0 and 1 and subtract it from the number 1, we get all these calculations. So when we get to the spreadsheet, we want to do 1 minus the probability of x being less than or equal to 1. So this includes 0 and 1. And if we subtract it from 1, we get 2 through 15. And that works for every single distribution. So this concept we're going to be using literally for the next several weeks moving through the semester. And so if we go back to the spreadsheet, we have the probability of, it'd be 1 minus probability of x being less than and or equal to 1. So in this case here, we do equal sign and then 1 minus, and then you put in your binomial function. In this case, the number 1. Trials is 15. Probability again is 0.3 and it's less than or equal to, so we type in true. And you can see we get 0.9647, so 96.5% in that probability part. And if you look back here, you see that you had to calculate the 0 or 1 and then subtract it from 1. Again, a very tedious calculation, and you could see, get the exact same number. So what about the last one? Well, let's do this last one. So 1 and 4 inclusive. That's part D there. And so what do we do in this case? So that would be the probability of 1, 2, add all these up, right? Plus probability of 3, and plus the probability of 4. So we could do all 4 of those separately and just add them all together. And for a discrete distribution, you can do that. You won't be able to do that with a continuous distribution between 2 points. So I'm going to show you how to do that now so you can kind of get used to it. So remember, we have less than or equal to. So what are the ones we don't want? Well, we don't want p equals 0 and p of x greater than or equal to 5, right? Those we don't want. So when we do this calculation, what do we get when we do x is less than or equal to 4? Well, when we do that one, we get p equals 0, 1, 2, 3, and 4. You see, we got all 5 of those now. But we want to get rid of this one. So how do we do that? We just subtract it, right? So if we set it up this way, x less than or equal to 4 minus p x less than or equal to 0, you would see that you would just get these 4 numbers here for probability, and that's what we want to do. And you'll see you have to do it this way in a continuous. There is no such thing as a single point in a continuous function probability-wise. We will get to that sooner rather than later. So stay tuned for that. But to finish this last one, this would be the probability of x less than or equal to 4 minus the probability of x less than or equal to 0. Whoops, not plus. And so when you do that calculation, it'd be equal sign, and then binomial. And so that would be 4, 15, not 14. It's easy to type a wrong number in, so you always have to be careful. And this would be true. And then you want to subtract the 0. So it'd be 0, 15.3, and true. You can see you can get a little over 50%. And if you try to do those calculations, you would add up each one separately, 1, 2, 3, 4. Again, quite tedious. But if you did that calculation, again, you would get a little over 50%. So you'll see that there's ways to use tables. That's how I ended up learning how to do this way back when. You can see there's a couple stars here. We really don't use tables anymore since the technology gives us all this. But kind of look up tables given this aspect. Again, not hard, but very tedious. And you'll see that there is a way to use your TI-84 and 83 calculators. These are, I believe, have them both built in. And the book goes over that in detail as well. You see there's two different binomial distributions. One is an equals and one is a cumulative. See, less than or equal to, just like the spreadsheet. So this first one would be a false in our spreadsheet. And this second one here, the CDF, would be true. So you can walk through that if you're interested. And so the last part of this lecture will be calculating mean and variance, and we'll go through a couple of those examples. But I think this is a good place to stop for this recorded lecture, and I will finish section 6.2 in our last lecture, last recorded